Let's solve this 4-term polynomial inequality, and then we're going to graph the solution set on a number line and then give the interval notation of that solution set. So this is my polynomial, 4-term polynomial, 1, 2, 3, 4, and it's an inequality because it's greater than or equal to 0. It's not equal. First thing we need to do is make sure we have a 0 on one side, and we do. Smiley face. And then we need to factor the polynomial. So you have to remember how to factor a 4-term polynomial. And this one here is set up to factor nicely. I'm going to get my Spider-Man colors, my blue and my red. My groups, first group is blue, second group is red. When I look in the blue group, I ask myself, what can I take out? What's my greatest common factor between those two? And you can see that I can take out an x squared, and I'll be left with x minus 9. Drop down this sign. So the second group, my red group, whatever I factor out has to be a negative. And what's my greatest common factor here? It's just 1. There's nothing else I can factor out of both of those. So I'm going to factor out a negative 1, which will change both binomials. It will become x minus 9. Okay, positive x minus 9. Now you can see that the x minus 9 and the x minus 9 is the same in both the blue group and the red group. And when I factor out that x minus 9 out in front, I will be left with just x squared. Make that purple again. X squared minus 1, and then that x minus 9 is multiplying it out in front. Alright, is this factored completely? Is this factored completely? No, it's not. This is the difference of two squares right here. So let me factor it completely. I have x minus 9, and then this is going to be x plus 1, x minus 1. Greater than or equal to 0. Okay, so you might need to look that up. Right, if you need a little more help on that last one, that's the difference of two squares, and you can look up factoring the difference of two squares. Okay, I have completely factored this polynomial, and now I can go to my number line. I'm going to put my boundary points. I have a boundary point here at 9, I have one at negative 1, and I have one boundary point at positive 1. So let me go and show that on the graph. 9 would be the farthest one to the right, 1 would be there, negative 1 will be here. I'm going to test a point in between every one of these. So let me get a different color. Let's go with, let's see if yellow's good enough. In between here I'm going to test 0. In between here I'll test 4. Out here I'll test 10. And back here I'll test negative 3. Okay, 4 points to test. I'm going to plug them into the original equation, see if they are true or false. Let's do that. Alright, first point to test is negative 3. So instead of x, I'm going to put in negative 3. And instead of x, I'm going to put in negative 3. Instead of x, I'm going to put in negative 3. And you know what? That color's not so great. Let me try a different color. Alright, that looks better. Okay, negative 3 to the third power. That's negative 27. Minus 9. Negative 3 squared is 9. Minus a negative 3 is a plus 3. And then plus 9. So we have negative 27 minus 81 plus 3 plus 9. Put that in your calculator. I get negative 96. Is negative 96 greater than or equal to 0? The answer to that is no. So nothing in this interval is part of my solution. All right, let's try our test point of 0. Everywhere I saw an x, I'm now going to put 0. Zero to the third power is just 0. Minus 9 times 0 squared is just 0. Minus 0 plus 9 greater than or equal to 0 is 9 greater than or equal to 0, and the answer is yes. So everything in this interval will be included. I'm going to shade it. Let's try 4, test point of 4. From the original, everywhere where I saw an x, I'm going to put in a 4. And let's see what we get. 4 to the third. 64 minus 9 times 4 squared is 16. Minus 4 plus 9. So 64 minus 144, gross, minus 4 plus 9, greater than or equal to 0, and calculator time. 64 minus 144 minus 4 plus 9, negative 75. Is that greater than or equal to 0? No. Okay, so the test point 4, everything in this interval between 1 and 9 is a no. We have one more test point right here of 10. Let's plug it in for x and let's see what happens. Everywhere I had an x, I'm going to put in a 10. And now 10 to the third, that's a 1 followed by 3 zeros, that's 1,000. Minus 9 times 100. Okay, I'm just going to put 900. Minus 10 plus 9. All right, calculator time. 1,000 minus 900 minus 10 plus 9 gives me 99. Is 99 greater than or equal to 0? Yes. So any number in this interval here is going to give me a true statement in my original equation, my original inequality, I should say. All right, am I going to have parentheses or brackets? Well, that depends on this right here. It's greater than or equal to. When I see that line, I know I'm going to have the thing made of lines, which is brackets. So I will have a bracket here, I'll have a bracket here, and I'll have a bracket here on the 9. This is what my graph's going to look like. When I go to interval notation, if my graph is good, I'm going to have everything from -1 to 1 in union with everything from 9 to infinity. All right, I'll put it over here. Interval notation. So it's everything from -1 to 1, bracket, bracket, in union with everything from 9 to infinity, including the 9, including the 1, and including the -1. Okay, let me do a little sketch to show you what this polynomial looks like, and you can see for yourself the places where it's greater than or equal to 0. All right, and I have a very crude sketch over here in red, and you can see that the parts where it is greater than or equal to 0, I'm going to put that in yellow. So that's going to be, it is 0, it's greater than 0, it is 0, and then once again it is 0 and it's greater than 0. You can see how there's two intervals where that happens, and that's these intervals right here.